Welcome to the Split Range Control Workshop. In this workshop, you'll gain experience with split range control and see how it is used in a common application. In the first part of this exercise, we'll be using the splitter block and examining how it can be used to adjust two manipulated parameters through adjustment of the splitter set point. We'll then be looking at how this is used in combination with feedback control to provide automatic regulation of two valves to maintain a control parameter at set point. In this exercise, the process is a heater-cooler that are used to maintain a temperature of a liquid product to a process. This temperature is measured and is used in a PID control. That PID control then is adjusting the splitter set point that is then regulating cooling and a heating valve. So let's look at our workshop. In the workshop, we have a dynamic simulation of the process in which we have the disturbance input to the process as well as the heating and cooling valves. Those all are used in the simulation to determine the outlet temperature that is used by the PID that is set up to adjust the splitter set point. To do the first part of our exercise, we're going to put the splitter though into automatic control. In automatic control, this means we can set the set point of the splitter. And as is indicated in the workshop, we want to adjust this over a range, so we'll start with 0%. And you notice under 0% the cooling valve is completely open. It's at 100%. By changing the splitter set point to 25, we notice as a response to that the cooling valve is reduced to 50%. Under these conditions, the steam valve is completely closed. When we change the splitter set point to 50%, we notice that both the cooling and the steam valve are closed. By adjusting the splitter set point higher, so we can change it up to 75. At 75%, we notice that the heating valve is now 50% open and the cooling valve is closed. When we change the set point to 100, then in response to that, the steam valve or the heating valve is full open and the cooling valve remains closed. So this is a good example of how the splitter block can be set up and adjusting. So we'll set the splitter back to 50% where neither heating or cooling are being used at that point, and let the process settle out at a new temperature so we can better visualize the impact of a splitter and by looking at a chart here. In our chart, we notice that as we change the outlet, the splitter set point to 0, our steam valve was at 100, and as we increased in the splitter set point, we went from heating or cooling to heating until we at 100% on our splitter set point, we were at full heating valve. With the neither valve being used, the temperature now settles out at a new value that's equal to the inlet temperature to this process. To demonstrate the value of using feedback control in combination with the splitter, we will introduce a disturbance into our process. And then we will manually try to adjust the splitter to bring us back to the original temperature, which I believe was 150 degrees. So we will change the splitter, and since we're now above 150, we can change the splitter set point to be lower than 50, which means we'll now be using cooling. So we make a guess at how much we have to change that, and we can see that in response to a change that the temperature of the reached our 150 degrees yet. So it'll be necessary to make another manual change in our splitter, and so we'll do that by again making a guess at how much we're going to have to reduce it. And as a result, we see that the more cooling is now applied and the temperature goes down. But unfortunately we made too big a change, because now the actual temperature is below our original temperature of 150. So this demonstrates the challenge of manually adjusting process inputs to try to maintain a process output at some desired value. By using feedback control, that is PID control, in combination with our splitter, we can adjust both valves through the feedback control by putting our splitter into cascade mode. In cascade mode, then the output of the PID is setting the splitter set point, much as we were doing it manually. And we're going to put our controller into auto, and you notice in this case it's set up where the set point isn't tracking PV. So when we have it in auto and the splitter into cascade, then the splitter set point will automatically be regulated to achieve our target of 150 degrees. So as we can see, as soon as we had automatic control, the temperature is starting to change and is coming in to target. We can better visualize this by looking at a chart. And in the chart we notice that where we put the splitter into cascade mode, then the PID was able to then start adjusting the splitter set point, and in response to that, the temperature is now being brought into the temperature set point. So through automatic control we can adjust both valves using the splitter to address conditions where either heating or cooling are needed to maintain the proper process conditions, that is the target temperature of our process. So we hope this exercise has been helpful to you in terms of demonstrating the value of split range when you have two manipulated parameters and one control parameter. We hope you'll use this exercise to further explore split range control and the way it is used in combination with feedback control to achieve set point.